So here on the board, I'm just going to give you a brief tour of some of the units that we have on here in order to operate our mood ring. So over here on the right, we actually have the thermistor, which is currently bridged between this white wire, which is our measuring wire that goes into one of the ports on the MSP430, and ground. Right here we have a 20 kilo ohm resistor, which is bridging between VCC, the measurement, and then to the thermistor to ground. And what this does is it helps ensure that the voltage drop across the thermistor never exceeds 1.5 volts, at least in the range that we're measuring. So what happens is that the ADC reads the value at this point, this voltage, which is usually in the range between 1 and 1.3 volts. And then what happens is that this multicolored LED, which we are controlling on two channels right now, the red channel and the blue channel, is adjusted using pulse width modulation to give the effect of dimming one color versus not dimming another, and we can regulate the color between all red, all blue, or a purplish gradient in between. So taking a look at the code, I'm going to walk through the parts that I find the most interesting. In my version, I have a couple of global variables up here defined. We have an array index and an array of size 8. And these are used to store the 8 most recent values that the ADC measures. More on that in a minute. So in the main method, we do a lot of the same housekeeping things that we've done in the past, including disabling the watchdog timer. What it basically does is it sets the auxiliary clock to source from the very low oscillator on the board. This is done because we have to operate in low power mode and use an oscillator that isn't disabled in low power mode. Then we call all these helper methods to help initialize the array, configure the LED, and the interrupts, and then the ADC properly. And those methods are all down here. Some interesting things is that the ADC we set to have a reference voltage from 0 to 1.5 volts. That's because, as I showed you on the board, we have a resistor in series with the thermistor, and by setting this reference voltage, we lower the range that we're actually sampling from 0 to 1.5 volts as opposed to from 0 to VCC. And we can do this because we know that, at least in the temperatures that we're measuring, that's the range that we're only going to see. So we set those references to be on, and we set the reference to be from 0 to 1.5 volts. Below we have an average function, which is called every single time that we decide to change the color of the LED. It simply just sums over all the values in that array that we were talking about above, and then divides by 8, or does a bit shift, which is essentially the same thing. The bit shift was done because the MSP430 divisions are quite expensive, so doing other ops when possible is a better option. Then we have a configure for the timer interrupt, which the interrupts are actually down here. I'll talk about those in a second, but when we configure the LED, just basic PWM stuff, we set the mode to be 7, which is reset set. We source from the auxiliary clock and set the appropriate ports for the LEDs that we're using. For the interrupts, we have one interrupt down here, which all it does is that on a certain time period, the MSP430 will wake up and ask the ADC to sample another value. When that value has been sampled, then this interrupt will get called, and then we simply add the value to our array of values and then move the array index up. And then we check to make sure the array index doesn't go out of bounds. And then based on the value that was computed for the average, then we set the percentages of the duty cycle to the appropriate values between 700 and 800, which were the register values that I determined were on the pole ends between hot and cold.
So if I take my finger and I put it on top of the temperature sensor to warm it up a bit, what we're going to see is that the LED will begin to change purple, gradually purple, and then go to red eventually once it gets really warm. And then if I pull my finger off, then it'll gradually go back to its cool color again.